Imagine this. You've just graduated from university as a software engineer, and you got a job as a software engineer at Google, at the headquarters in Mountain View, and you're making good money, $150,000 a year. You found the love of your life, you're about to get married, settle down, build a family, and start having kids. So all you need now is the perfect house to build a family. So one day you go out, with some friends and you find the perfect house. You found the house of your dreams. You say to yourself, I want a house that looks just like this. There's just one problem. When you go on realtor.ca, realtor.com to find a house that you want, there's no way to tell a website, there's no way to say, I want a house that looks like this. And the fundamental problem and the reason for this is that humans, we think visually, but computers, they think numerically. So there's never been a way for us to search for homes that we like and that we want in a way that actually match the way that humans think. Until homes like this.
So we're a team of three students, Tomiwa, Brian, and myself, Forrest. Since we're a small team, we were able to work together and solve problems collaboratively. Some of the responsibilities we took on included Tomiwa led the research and implementation of our image recognition algorithm. Brian did a lot of work on the database management, while I managed the front-end development and integrating our program with cloud services. Before we go on with our demo, Brian will go through a market overview to highlight why our program is needed in the market.
All right, so to give a brief overview of the existing industry for real estate services online, there was actually a survey conducted by Zillow, which is one of the largest real estate search websites, especially in the US. And this survey actually revealed that 89% of the survey respondents reported using an online real estate search website the last time that they were looking for a home to purchase. So websites are by far the most commonly consulted information channel for prospective home buyers. And we can also see the magnitude of the industry in Canada as well, because Realtor.ca is the largest real estate search website in Canada. And in 2018, they reported that they had over 42 million visitors and 885 million property views. However, as Kamiwa mentioned, these existing websites don't really align with the natural way in which humans think about their dream homes, because all these existing websites really only allow users to filter their searches by traditional numeric or text-based options. So you can search and filter by, for example, the number of bedrooms or washrooms that the house has. You can set a price range. You can filter by the total square footage of the house. But there's really no way to tell a website like Realtor.ca, hey, I want a house that looks like this. And so in order to solve that problem, that's why we developed homes like this. So just at a high level, this is a list of the features that we've implemented in homes like this. So the core features really have to do with allowing the user to upload an image of a home that they like, and homes like this will return a list of similar looking houses that are available for sale. And so Forrest is going to go over the more detailed description and explanation of the tech behind the product in a bit. So I'm really going to talk mostly about the features from the user's perspective. So we have both a desktop and a mobile version, and the mobile version is integrated, with the phone camera. So the user can take a photo on their phone, or if they have a photo already on their desktop computer, they can upload that to our database. And essentially, our program analyzes it and creates a numeric representation of that image, and then compares it to the numeric representations of all the other photos that we have in our database. And we have 5 photos for each house in our database. So we have a photo of each house's exterior, the washroom, the master bedroom, the living room, etc. And the user can submit any photo that he or she wants. So if they submit a photo of a living room, for example, our program will return similar looking living rooms, but then the user will then be able to click on individual search results and see the rest of what the house looks like, as well as additional details such as the location and price of the house as well. Other additional features that we've implemented, we've also created a Python script to update our database in real time with real listings. And we also have a feature as well to allow users to see their past searches.
All right, so at a high level, our image recognition algorithm revolves around convolutional neural networks that TensorFlow takes advantage of. So when we input an image, the first layer is the red, green, blue pixels, and through various layers of calculation, each calculation will reveal a feature map. all the way to the second last layer, which is a 2048 dimensional vector. This 2048 dimensional vector will then be plotted against all the existing images, each which have been broken down into this vector, and using approximate nearest neighbors, we can find which are the most similar images. Tomi will now explain the architecture of our program and then provide the demonstration.
So to show you guys how homes like this work, we're just going to show you a live demo. Let's say, for example, you're on Pinterest and you're looking for living room design ideas, and you're looking for houses. Ooh, I like this one. And so typically, so now the question is, how can I find houses that are for sale that look just like this house? Very simple. You get the URL to the image, put it in here. And so what it's doing in the background right now is that it's basically converting that image into numbers that computer can understand, and then finding the most visually similar images. So based on that, we can see that these are the houses that our algorithm thinks looks just like this. And so our architecture is client-server architecture. So on the front end, we have a React client that the user interacts with, which is just the website that I showed you. You send the image to the Firebase server and it returns the URL of the processed image. We then take that processed URL image and send it to our Python server. And Python, we use a TensorFlow framework. And with TensorFlow, what we do is that we use a TensorFlow package called ImageNet. And the last layer of that neural network is a label, as you can see here, telling us what types of images we have. Now, we actually can't use labels to find what houses are visually similar. So what we do is that we take the second last layer of the neural network, which is basically a 2048 vector array. Which is, so this is the two hits of the API. So image features returns a feature vector. We see 2048 elements, and each of those numbers is basically a numerical description of our image. And then so what our k-nearest neighbor algorithm does is that it uses a framework called Spotify Annoy index, and basically what that does is that it says it takes those numbers and basically finds the cosine similarities between this 2048 length array and other 2048 length arrays in our database, and says find me the nearest images, find me the nearest numbers, and those nearest numbers also correspond to the nearest image.
Alright, now we're going to do a demonstration of our mobile website. So this is our homepage. Let's say I'm just walking down a street and I see a house that I really like. For example, this one. What I can do is I can pull up our website, tap right here, and go right into the camera. And since it's integrated directly, I can just take a picture of this house. Just like that. So now what's happening is our picture is being uploaded onto the website. As you can see, that's the thumbnail. I'm going to hit Find Homes. Alright, so now the labels have pulled up, which shows what it detected in that picture I just took. As you can see, the first result is the same as the picture I took, which means that the search algorithm is working. And these are some similar houses that were detected by the algorithm. Now I can actually go into the result, tap into the house. And now I can see details such as the price, size, the location, as well as the real estate agent. And I can contact the real estate agent directly by hitting his phone number.